Hello everyone, I thought I'd share this silly project with you just because why not? I've been working on this basically simple LED strip driver, and it was just for a sat lamp that was only 50 watts. The first iteration was so basic, it just had a simple fuse. Not any of this because I'm driving them at 20 kilohertz, and that's like a 30 microsecond rise time, which is absolutely nothing. But I figured I'd show you my new circuit. Apparently JLC PCB offers free, not free, but like for the same price, 4-layer upgrades for their PCBs under 50 by 52 millimeters. And I thought that's fantastic, and I didn't realize the 6 layers are also the same, and now I'm looking for an excuse to use 6 layers. Oh my god, I could make a fancy IC with like high signal integrity requirements. Anyway, I used 5 low MOSFET drivers here, not because I need them, but because people will really mad if you don't use MOSFET drivers, even if your application is absolutely 0 requirements. You might have noticed that I used 5 instead of 1, 2, like maybe 1 3-channel, 1 2-channel. That was because it was surprisingly cheaper because I get to order them in bulk, so I get the discount. Ow, my jaw hurts. I added some TVS diodes, which is, not really necessary for a hobby project, but this is going to be standing behind my monitor for ages. It's good. This was the bane of my existence. There's so many weird resistor values that I had to order, and it's also a pain to calculate these because there's so many. And also, for my application, this rise time and the power is kind of really high at 24 volt. This is not really great for that, so I have to set a really long soft start. Thankfully, it works fine at 150. And that's like the sweet spot region that I've found for this by just, not by doing it properly, but just calculating around it and seeing the values because I'm lazy. Here you can see it's just some simple dumb diodes. Oh my god, I hope I actually remember to order these diodes. I just remember that if I forgot, I'm gonna cry because there's $50 shipping. Anyway, this IC is the Nightmare. And it was also $2 each, and I bought 2 because I'm gonna burn one, knowing myself. So, oh, it was so expensive. That $2 doesn't sound like much, but it just really adds up. Anyway, I had an LM1317L for the gates because I needed 10 volts for the gates. It's not gonna draw that much current, so it's okay. This one's nice because it has low minimum turn-on current requirement, which any of you might not know, but apparently a lot of linear regulators, especially the old school cheaper ones, have a minimum current use requirement. So if you don't draw a specific amount of current, they freak out. Hence the very low ratio of the very low ratio with a very low value here. 470R is pretty low for a, voltage divider or like a signal like that. As you can see, my beautiful schematic drawing, I've put this part out, but anyway, the previous version, I had some minor transient issues with the ESP. It was pretty low noise, like 17, but especially at 24 volt to 33.3 volts, it was a pretty huge decrease, right? And it was not handling transients very well because the ESP would just freak out sometimes and just draw a lot of currents. It was not the end of the world, but it would have like 40 milliwatts of noise, which is pretty bad, especially at 24 volts. So use this new IC. This is also 2.2 megahertz instead of 1.1, which is the old one was. I actually kind of really love this buck converters. They're so easy to configure. There's even ones without the feedback pin, so you can just like not do that. My old one was actually just 3.3 because that's the voltage I use almost every single circuit. Anyway, this picofarad is apparently for improved transients. Think of it as like a luxury lane for high frequencies, the way I think of these capacitors. I think I might be wrong here. I'm not sure if this is the same thing, but if you're ever seen a scope probe, it kind of has something similar that you can adjust. Well, technically you adjust the other one, but you could pretend you're adjusting this one. You can adjust this one. Anyway, the point is, wow, that's just real nice here, just zigzag. This will improve the transient response. I'm actually kind of suspicious. I'm actually surprised this works though, but the schematic suggested this, and I'm like, you know what? The schematics can't lie. But I feel like this would just make the driver freak out really hard, but I've got to study this more, see how it works. Anyway, it's 1 microfarad, 1 curve, blah, 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 doesn't matter. I put a little LED, I put a little UMCC connector. I forgot if that's what they call this, like IPX. It's for antennas, but I use it for my scope probe because it's easier to use a BNC cable to your scope with like 50 ohm termination to measure the noise. This is a series termination resistor. I'm not sure if it's gonna work that well. I've never actually done series termination before, but. And if you don't know what series termination is, please Google it. Standing waves are just fascinating. Physics is cool, and this stuff is wizardry. Anyway, I put like a bunch of capacitors. You used to have only 210 microfarads, 20 for the old one because it was 2.2 megahertz, and I perfectly picked that one to the perfect characteristics for this buck converter, so I can hopefully remember that when I'm to use it for the future, because it took me a long time. And just an LED on. This is a connector for, you know, ripple testing, because I shorted and killed like one IC and like 3 of these MOSFETs because my hand slipped, and I shorted everything in the circuit while probing. This I'm not super sure about, but I figured the calculations tell me it's good. The issue is that if you go too high, your transient response dwarfs. So anyway, these are also just vibe picked, as I like to call it. They were not really calculated. They just seemed like the right vibe. I actually don't know how to calculate these things pretty well, if I'm being honest with you. These ones I picked for their resonant frequency, 10 microfarads. This package size, sorry for my voice, it's kind of sore. They tend to have really good low ESR at 2.2 megahertz, which is 2.1, which is exactly what this one uses. So that's how I picked these. But these ones are just kind of white picked. Anyway. I think this new version does better, even though it technically doesn't matter. The ESP is okay with that unless you're doing sensitive analog measurements, which I'm not. The little buddy here, the little TVS diodes, wee, so many of them for the programming interface. I wish I just put test beds here. I saw this connector and it's like $150 for a bunch of pogo fins, and I'm just gonna DIY it because that's ridiculous. Oh, that's another probe interface in case this one doesn't work out well, because it's my first time doing series termination. I don't want to order another PCB. Yay, ferrite bead, because why not? And I put like 5 channels because I'm only gonna I figured that I'm gonna just have this PCB, right? And if I'm gonna use this one for this project, I'm just gonna solder this. And you know, I don't think many people use 5, but you sometimes use 4. So I'm like, I'm gonna get 5 of these, might as well make it versatile. And this fuse IC is basically there mainly for the soft start, but because the NTC resettable fuses, I found that the right size for my circuit was as big as my circuit because it's 24 volts. And at this stage, it would be something like, I forgot, 5 amps. I think that's 5 amps, 100 watt-ish. You can see my calculations here. Bloop. I wish I bought the ones for 2 amps or 3 amps, because this is actually going to be realistically the 3 amps for me, so I could like choose what. Oh my god, I could put a little jumper here so I could choose the current limit for myself in the future with like a selector switch. Although that might have actually interfered with this pin because this has a capacitor that oh wait, no, that's not the one with the capacitor that discharges. Sorry, never mind. I'm being stupid. I actually don't know how this I limit pin works because you need this here. Anyway, it sounds like something a capacitor would do. I don't know. It sounds very capacitor-y. Anyway, I don't know how it works. I have to see the data sheet. Data sheets and giggles. Bloop. Can we just admit that designing footprints is the worst thing you can do in PCB design? Why is it not automated? Why do we have like an automated, like, you know, internet thingy where people design it? And they like, I'm not talking about Snap Magic or whatever, where like a built-in KiCad hub where you can just upload your designs for a specific IC so people can actually download it. And TI is a nightmare to deal with because they have a lot of really weird broken packages on their own website, which is embarrassing. Anyway, this is my PCB. Bloop, 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 bloop. Sorry, I keep doing that. I figure since I have 3 lanes, I could do this, which is not ideal, but yeah, it works. This is my eFuse IC on the back. Thankfully, it's not that bad. I managed to do 2 layers because this is a 4-layer board. You don't really care if you, I mean, you do care, but it's not a big deal if you put components here. This is just a heatsink. I've actually not removed the solder mask for this because it's only dealing with like 10 milliamps. And this board is, it's gonna get a little warm, but it's not gonna get toasty. It's beautiful. These are my fuses. Sorry, TVSs. This is my fuse IC, soft start, blah blah blah, because there's just giant capacitor here that makes everything spark. I'm hoping the TWS diode I put somewhere. Wait, why did I put this here? Oh, thank God, that's just a Schottky diode. Okay, I actually don't know what that's for. It's between out and forgot exactly what that's for, but yes, I have this to take care of the flyback, whatever. And these are the TWSs for the inputs, which to be honest, these are nice because you two touch things. You know, these are like kind of touchable, I guess. I don't know what to call them. But this is just ridiculous. Just you only program your board once or twice unless you're debugging, but I think these are overkill. Yeah, it was really nice to have like all these layers because you do like worry about the little holes they live in your ground plane. Do you see these? These are not nice. But they're so small, and unless you're dealing with 2.4 gigahertz, it really don't matter usually, unless you're not crossing over them. These are just my dumb programming thing. I'm not going to actually use this, but these are sometimes nice to put a resistor there, have jumpers for them. And yeah, these were cheaper. There was nicer packages, but this was the cheapest one I could find. I used too big of a screw terminal, but I could have used a smaller one. I'm gonna use a screw terminal here. I was gonna use a connector, but it takes so long to not just figure out what fits what and design a footprint and worry about the current, and you gotta find a matching connector on the other end because socket receptacle BS. But anyway, I gave up. This is a probe thing I've designed. I've never used it before. It's my first time, but this is for just probing. The lane, in case, as I said, this one doesn't work out, but you can see it's just terminated here. It's not a very great connection. Just one? Yeesh. I did not notice that actually. I should have. Is that really just one? Okay, that's just using one. I mean, it's not like it's drawing a lot of amps, but I should have used more than one maybe. So yeah. These are just noise capacitors, and I feel like I put this here. Let me just get the 3D view. The reason I put this buck here, oh my god, look at these chunky boys. I've never seen a capacitor this big before, believe it or not. I've never had to use so many. I'm not going to use this one. This is like an optional capacitor I put the slot for, but anyway, this is like I drew an outline of my buck and I forgot to move these actually. Whoops. Too late. I did this really weird thing with the wing because they're coming from the underneath the bottom layer and coming up here. And the reason is because I didn't want to put my buck right next to my ESP, which is both dealing with frequency and it might just like not like that. So I put my buck on the opposite end, so this is why the layout is a bit awkward. Thankfully the 3.3 volts just comes straight off here. And I have 4 layers, so I don't really care too much. It's nice to not have to use wires, but it's not the end of the world on 4 layers. And you can see another one, chunky boy. And of course, every PCB needs the emotional support bunny. How could you not put a bunny here? Look at that. Bunny. 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 Anyway, this is actually not the right controller. I found the cheapest ESP one, but this is not the right model, 3D model for it. But I was like, it's the right size. Looks pretty. Helps. I had to put 0402 here because I ran out of space on my PCB. Technically, I guess I could have squeezed them here, but it wouldn't be as close to the IC. These are really transient heavy. They're very fast because, you know, the rise time I think is going to be around 5 nanoseconds. So I put them here in the bonus. The 0.02 package is less inductance. And these are only 100 nanofarads, so I don't care for them, but they're small. These are chunky 10 microfarad boys. They're only 3.3 volts, which is good because if you are trying to get a capacitor at like 5, 12 volts, good luck in ceramic. You gotta stack like 5 of these to even get anywhere near decent actual capacitance in this package. This is funny, but because of the high rated ones are actually genuinely just stacked on top of each other sometimes, and they're like $5, $2 each. It's annoying. I put this here because I'm sadistic and I want to see if I can solder 0201 by hand. I don't know why, but I just think it's funny. And hey, if I can do it, it's not that hard because it might be actually not as hard as people make it. I could keep on using them, right, for very compact packages. There's like PCBs that are space constrained because I do a lot of space constrained PCB because, as I said, I'm sadistic. Here is a 04042. I've actually soldered 0402. I don't know what the big deal is. It's pretty easy. I mean, I guess I do. Without a microscope, it's kind of a pain. Or if you're not using hot air or hot plates by hand. I've done it before without a microscope, but I bought myself a microscope. I don't have anywhere to put it anymore because I moved, but blah, 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 blah. Anyway, I actually bought 2 inductors, which if I'm not lazy enough, I'm going to compare. It's a fancy Boyle Coldcraft inductor, but I bought a cheap Chinese one. And I was tempted to not use the molded ones, to use the magnetic core wrapped boys. with the like glue they put on it for the EMI. I don't know if that's gonna be as good as this. I actually am too exhausted right now. Probably gonna take a break before trying that, but I figured maybe I could try those, right? Maybe they're not that bad. Cause, you know, I don't wanna generate EMI. I don't know why I care about EMI. It's not gonna pass certification, but it's nice to have good habits, you know? And I'm not sure I'm gonna solder these because I was gonna use a hot plate. I actually impulse bought hot plates in the beginning of February with a nice JVC, sorry, not JVC, JVC clone station. I've been wanting one for 2 years, sorry, 1.5 years, and I finally got it today, actually, this morning. And oh my god, it's so good. I should make a video about it. But yeah, this IC was pretty expensive. Trying to see if I can talk much more about anything interesting here. There's not many people who like doing this for a hobby, so it's hard to find people to talk about it. So I'm going to do like a little outline here as a heatsink for these bad boys, but I've realized that it doesn't work like regular heatsink. I think that would help. It would make more sense to just do a giant copper fill, right? Because you do the little fins, because air is going to pass through them, but this doesn't work like that. And you don't actually increase the surface area, you reduce it because it's almost 2D, you know what I'm saying? It doesn't have much thickness, so it's not going to work like that, so I didn't do that. I didn't actually fill it either. It's just kind of live in there. I figured these are not going to generate that much heat. They're like 40, like I think 20 milliohms, and the load is like each channel can technically handle 4 amps or 5 amps, but I designed it so, you know, the combined channel is like, I don't know, 100 watts. I designed it for around 100 watts. But the fuse is set to, I think 4 or 5 amps, so it's like 4.5, maybe leave it some margin. 24 times 4, let's just say 4. Yeah, 100 watts and divided by, let's say 4. Actually, that's a little bit unrealistic. Let's divide it by 3 because your RGB channels usually are low wattage. Let's see. That'll be 22 watts each channel. 22, I don't know why I'm doing it like this, but blip blip blue, 1.87, that's pretty low actually for the grand scheme of things. But you can just, you know, put this both here. I just realized how insane 100 watts of LED is anyway. You're gonna go blind unless you're doing something like me, which I'm gonna show you later. So yeah, this is, I actually thought I would have more to talk about this, but it's just pretty simple. Took me days, if not just surviving off Vietnamese subs, to design this. I don't know why, because there was 3 iterations. It's a long story, but it worked, and it worked fine. I had no issues, except a little bit of issue here, but it was not actually causing any issues. I was just unhappy with the performance of this, with transients that this guy draws. So I went all insane. And blah blah blue. Blippity blob. Okay, this is the second project I'm working on, which I haven't actually ordered yet, but I've ordered the parts for it. Most of them, actually, I think, because I was ordering that and I already knew some of these parts, so I ordered it with it because shipping is $15. I might still have to put an order anyway, so it might not matter, but I have like 40 reels sitting on my desk in preparation for the order because I like organizing my capacitors and whatnot, and like little tiny printed assembly reels. Anyway. This is here because some fans, they're very rare, but use 5-volt pull-ups, and I don't want to draw 5 volts into my ESP-H2 Mini. This is thread compatible. I kind of regret doing it, but it's kind of a pain to choose another IC again. And I already ordered the IC. Sorry, module. This isn't a module. You could put it here, but you have to use 4 layers. I really don't want to try this on a 2-layer board. It would technically work, but I just don't want to bother with that. And the difference going to be like 30 cents for a board, you know, if you're not doing a lot of production. So I just figure use the module, right? Save myself trouble, even though I kind of want to do it as a fun challenge, but I would use 4 or 6 layers for some. 4 layers, 6 is overkill. Something like this. Yep. Oh, and I had an RTC clock because it's going to be matter. It's not going to matter. Haha, pun. Oh, god damn it. I forgot to put this on my old PCB. Well, that's going to suck. At least it's in here and connected, right? You can just ask the internet what time it is. And it's not going to get unplugged, really. This is the LED driver. That's also expensive because why not? The annoying thing is that I'm not sure if this is going to work because it's a little bit too small, but I did calculate it. This is 2.2 megahertz, and the reason for that, despite the inefficiency, which I'm hoping this thing won't blow up because that's a lot of switching, it says it can handle it, so I'm going to trust it. The higher you're switching frequency, the more you can do PWM, the faster you can do PWM because you have more time for the loop to settle. That's basically why it's just such a high frequency. It's not like it needs to be compact, and this already has frequency spread whatnot for EMI, which is pretty good. And I forgot what I was gonna say. It also has two, like, can control the analog like level and the PWM separately, which I love. Absolutely, you could do like shallow PWM. I think you can do that. I'm not super sure right now. It might not work because this pin behaves a little bit weirdly, but I was confused by documentation. I'm gonna try it anyway. So yeah, I chose this because I want to do 20 mega 20 kilohertz, and I think once I reach below 3%, which is I think what I calculated as my minimum brightness with the 20 kilohertz, I'm just gonna switch the, I start switching the frequency down and doing all that BS instead of switching the, I guess the duty cycle will still be the same. This is a chunky boy diode, because why not? This is the big capacitor, which I white picked. Partially, I actually used it on my calculator. I don't know what it was calculating, but I used that. Pull downs for this bad boys. I need to stop watching Adventure Time. I say that because of Adventure Time. I'm not going to use under voltage, but I figure why not put this. This is, NC means not connected. Kind of like, I should have put optional, but I put NC because these are just optional options the chip had. And I was like, this is not a space constrained PCB, so I didn't care. This is using a 12 volt little boy. Oh, sorry, this is a 12 volt boy. This is 800 kilohertz. The capacitor is inductor is really large. I'm kind of worried about that. I've never used an inductor with this kind of value before. I'm not sure if it's normal. That's what my calculations told me, eh? But yeah, I've white picked this one again. I partially white picked these ones. I did do some stuff here. Actually, that doesn't make any sense. Why are these 10 micro? I might have to revisit these. Anyway. This goes back to this, so it's like two stage, and this is 3.3 for a microcontroller, 2.1. I chose the different frequencies because this would not create some sort of weird awkward loop where they each try to like change each other in a way. Not each other, but like, I was worried the power draw pattern of this might mess with this if they're the same frequency or whatever. I've made sure this is much lower. Might not have been actually necessary, but hey, at least I get more efficiency, and I'm not space constrained, and this is not drawing a ton of power, so AMI is not the end of the world. And this is the reason I even have 12 volts on this board. I mean, it's kind of an insane jump. This board is 48 volts, so it's kind of a big jump, 48 to 3.3 volts. Actually, that's more than the margin most people recommend anyway. I guess I could have used 39 volts, but anyway, it's there for the fan. And you can measure tacos, which is really delicious. And I'm just gonna use an octo fan for my heatsink, and oh, I almost forgot. There's a thermistor, blah blah blah. It's gonna measure the temperature of the LED for safety features. It's gonna like scream if it like reaches that. Thankfully, I just use a gigantic. You kind of see how big these things are, but I use the jack anyway. This is only 3 amps. This is the programmer interface. This is my ugly schematic. I did this for fun reasons. Fair be, because why not? Yeah, it's actually not that complicated. I don't know why this took me so long. Mostly I was just calculating these stupid resistors that you need and the stupid capacitors. Why is there 1 nanofarad X7R capacitor here? Why is it X7R? It's just 1 nanofarad. I'm actually confused by this. Anyway, I'm not gonna worry about that right now. I feel like I should have used the MP0s, but for some reason maybe it didn't require it or whatever. Anyway. Boop. I love the sound effects I add to everything I do. Boop. Ta-da! This is the ugliest schematic I've ever had the displeasure of laying my eyes on, but it works. I mean, I haven't ordered it, so who knows, maybe it doesn't work. Try to keep these two PWM signals away from each other. I have some ground wires in between. This is not exactly, gigahertz or megahertz. It's just 20 kilohertz. But I figured, still don't want to interfere in each other, because these are both just going this way and gotta be not nice. These are just the measuring boys. I'm not very happy with this loop, but I couldn't figure out a better way to do them. I'm also very unhappy about the signal here. I wish your keycap would solve your color presence, because I like coloring my signals blue. Let me see if I can just do it again. KeyCat is, I appreciate everything they have done, but KeyCat can be annoying sometimes. Why is this not working? Jeez. Okay, I'm gonna worry about that later. Then my thermistor is not bad. This is the enable, which is bad. These two are very long, and I hate that. I chose to do 12 volts vias because this is on our switching, so the vias are not going to act like antennas, but the distortion here is above a PWM pin, so I feel like there's a lose-lose situation, but this is at least a little better. This is my 12 volt lane. It goes here through this, and I could have put this here and put this here, but it was too late by the time I realized, and I didn't want to bother with that. It would have probably been a bit nicer, but it would take a lot of effort. This is my shunt resistors with the fan, nice connection. I put these as close as I could to each other, hoping that they would get the same level of EMI, be closer to each other. So if they raise, because this is differential, kind of, you would think of it as like they're measured differentially, right? So you would want them to be close to each other. So if there's noise, it's gonna like nullify each other, I guess, because they're both going higher. This is the inductor. I try to keep my inductor loops as small as possible, but I did try my best here. It's kind of a, not sure which part of it stops being a loop, but this kind of a giant loop, but I don't think that's what the loop really is. It's like this here. My giant little boy. These capacitors are chunky. Oh my god, if you thought those were chunkers, look at this bad boy. This is a real chunker. And they were like $3 each, so I did order them, but I'm gonna cry using them. And I don't think I should have just went like with electrolytic or aluminum at least. Those are, sorry, polymer. Those are low ether or tantalum, but tantalum scares me even though they are not, probably not that bad. This doesn't have a 3D model. This is a gigantic inductor, as I said. I'm kind of suspicious that I needed this, but oh well. Fan connector, I know, very terrible position, very awkward. I decided to do this because I know the substrate does have the more dielectric loss, so the Wi-Fi signal will be better on this board. I don't know why I didn't do it with the previous one, it just didn't occur to me, but yeah, this is kind of nice to do if you're using a Wi-Fi module. Just make sure this port, oh wait, I'm an idiot, it was because it was already poking out. Okay, yeah, sorry, the previous module was already poking out fully, so I don't need to do this. But yeah, this one, I forgot why it's not, I forgot what, oh, because this is designed different, so the pins are here, so I couldn't, yeah, okay. The pins are, I think there's some pins here, it's very weird. I think I forgot why, anyway. So yeah, this is pretty crappy. I'm not very happy with it, but it's using the exact same thing, copy pasted, just laid out differently. This is the fancy boy. Oh, and this time I put a ground pin because I have the space, and this is for scoping around. I figured, you know, I'm not gonna use this actually, but I put it here because I have the space. That's my shunt resistor. Shunt. This is a slim inductor. So this is the PCB I finally designed. I'm gonna order soon. For my sunrise alarm, this is very crappy, but I don't think I want to spend the extra. If I could put some components on the back side, right? And I could make a 4-layer. This way you could get the cheap 4-layer and I could get better EMI, but it would be very hard to solder, and I'm not sure I'm gonna solder the other one because I'm using a hot plate, as I said. So usually you do the bottom side first and do the top side, but because I'm using a hot plate, if I populate the bottom side, I can't do the top side because the components are in the way, so I'll figure that out. I'm hoping if I do the bottom side with just hot air, it's gonna stay in place, you know? Hopefully. We'll see. Oh no, the bottom side is a hard one to solder actually, so I'll prefer using a hot plate there. So yeah. This, and you know, you're supposed to keep your feedback loop very away from inductors. Sorry, from your yeah, accelerator, right, actually. I'm not super happy with this, not mega far, but there's a lot of wires. Grounding wires here, it's not gonna, you know, completely stop it, but it's gonna help. I think that's good enough. I don't know what else I could have done here. Oh, I'm an idiot. I could have just done this. Boo. I'd have to use a via, but I don't think I'll care too much for that one trace. Yeah, you know what? I'm gonna do this. Yeah, okay, I'm probably gonna actually change. I just realized I could have done this and avoided the inductor. The distance would be like, actually this only would be marginally better. The loop would be lower, so it's like less chance for it. So would it be lower? Yeah, actually that would be a little bit different, better. Might do that because there's, you know, the feedback pin is very important to keep low EMI, especially from the inductor. There's a chunky box pattern, and this one's poking out, but I didn't want to adjust everything and make the board even bigger. It's not gonna bother anyone, right? Kind of weird, but it's gonna work. Yeah, I still don't know why it was just here. It should be here. Oh well, life is full of mysteries. This does not look legal. Oh, it is. Yeah, and I like to put these little wires around my inductors and switching circuit. Do you see there's like there's more wires around here? I put extra wires around my inductors and everything to make sure it doesn't spread. And the reason I did design this board like this, and I had the space to figure, since I couldn't fit it on 50 by 50, I couldn't just put all out. I was like, it doesn't matter anymore. I tried to keep this, although these two are kind of, you know, pointing at each other, but I tried to keep these two away from the rest of the circuit, which I guess I've not done that great of a job. Why didn't I push this down? I have the space. Okay, if I make another iteration, I'm probably pushing this down, but that'll take a lot of work. Because you have to reroute everything. KiCad is a nightmare sometimes. Sorry, I love you guys and it's free, but you know. You want to keep these away from the other one, especially this guy is switching at a high frequency. These two are switching at the same frequency too, which is like extra. I mean, not that it's gonna not matter if it's not. It's just gonna, I think it's gonna matter a little bit extra. Although this does support, these two both do spread frequency spectrum, which I mean they kind of vary their frequency with each cycle, so that, you know, it's kind of like a less concentrated burn, I guess, in a way. It's like more spread out of noise, which is good. So yeah, I don't know. Figured Bunny, right? Bye.